So the multiplication rule of counting helps us determine the size of the sample space without actually having to make a tree diagram or anything like that. Right? Tree diagrams are pretty limited. We could actually say that back here. So tree diagrams are the kind of thing you only want to do for a small sample space. I'll actually make a note back here. They're generally for small sample spaces because otherwise they get unwieldy. And that's why we don't want to do it for 6 kids, because 6 kids would be a large sample space. And so the multiplication rule of counting is going to help us figure out how large a sample space would be without actually having to do this whole tree diagram. So this was sample space of 4. This example down here was a sample space of 6. The next page had a sample space of 8. Tree diagram is okay for that, right? You can get up to 16, maybe 32 if you're pushing it, but it's getting a little unwieldy at that point. So the multiplication rule of counting will help us figure out the size of the sample space without having to figure out the tree diagram itself. It'll also help you figure out the size of your tree diagram if you wanted to make one, right? So it allows you to figure out the size without needing a tree diagram. And that's very useful for us because a lot of sample spaces are too large for a tree diagram to be useful, right? Tree diagrams are generally for very small sample spaces. All right, so let's think about the 6 children example, and we'll see how this goes. So you just, if you read what it says, it's saying, your first choice, you'd have P, your second choice, you have Q, third choice, you have R, and you just multiply them. That's it, right? So let me show you. So your first child, you have, again, we're assuming only male, female. So you have 2 outcomes possible for your first child. Then your second child, then your third child. That's where we stopped on the previous page. So we had 2 times 2 times 2, which is 8. So we had 8 for our sample space. But if you keep going and have 6 kids, it's 2 times 2 times 2 times 2 times 2 times 2. There's 6 children. First kid, second kid, third kid, fourth kid, fifth kid, sixth kid, which is 2 to the 6th power. In case you don't know that off the top of your head, it's 64, but I will show you how to find it. The caret button is how you get an exponent. So 2 to the 6, enter. It's 64. All right, next, you are going to randomly guess on a 10-question multiple choice quiz where each question has 4 options. Ooh, okay. So the first question, you have 4 options. So it's like A, B, C, D, E. The second question, you have 4 options again. The third question, you have 4 options. It's A, B, C, D every time. And I'm just going to keep going. There's 10 questions, and each of them has 4 options, right? So 4 options, you can imagine A, B, C, D, right? For that quiz. So if there's 4 options for each of those questions, then it's 4 to the 10th possible question, or possible ways you could solve that particular exam. Only one of which is all of them correct, by the way. So 4 to the 10th. Write that down. 1,048,576. So that's 1,048,576, for which you definitely do not want to make a tree diagram. No. That would be, well, not impossible, but pretty close. You're not going to do that. All right, you're going to toss a fair 20-sided die and a fair 8-sided die. We actually saw this a little bit when we were looking at the simulator online. There are different kinds of dice, believe it or not. Again, they're played with a game called Dungeons and Dragons, as well as various other games. So a d20 looks like this, and an 8-sided die looks like this. It has 8 sides, and this has 20 sides. All right, so when I toss this first die, the 20-sided die, how many options do I have? Well, 20 times, when I toss the second die, it has 8 sides. So that would be 160. Even though you're only doing each die once, it's still a lot of options. All right. Now, the first year, the state of Pennsylvania issued railroad memorial license plates. The license plates had a picture of a steam engine followed by 4 digits. Assuming that the repetitions are allowed, how many railroad memorial plates could be used? Okay. So they have a picture, and then they have 4 digits. What are the 4 digits? So when you look at your calculator, you may be able to see it. Digits are the numbers that we use to make phone numbers and, well, license plate numbers and so on. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the digits. There's 10 of them, right? Because there's 1 through 9 plus 0 makes 10. So you have 10 options for that first number. And they say assume repetitions are allowed. So in other words, you could be 9999 or 7777. So if that's the case, then there's 10 digits for the first option. Then there's also 10 digits for the next one, 10 for the next one, and 10 for the next one. So it's 10 to the fourth. It's almost the opposite of this question. This one had 10 questions where each of them had only 4 options. This one has 4 places. Each of them has 10 options, right? 4 digits, or yeah, well, 4 digits. In each digit has 10 options. So it's 10 to the fourth, which is 1 followed by 4 zeros, in case you didn't learn that trick from pre-algebra. Right? When you take 10 to a power, it's always the 1 followed by however many the zeros there are for the power. All right, now let's see here. Select 3 cards at random from a deck. Show both with replacement and without replacement results. All right, so let's do with replacement right here. If we take it with replacement, we're choosing, 3 cards. So there's 1, 2, 3 options, and you're going to multiply between the 2. When you choose your first card, it has 52. And when you choose your next card, it's 52. And your next card, it's 52. And so it's 52 times 52 times 52, which is 52 to the third power. There, like that. Which is 140,608. All right, now what if you take it without replacement, which is much more how card games are actually working, right? So if we say without replacement, it's still 3 choices because you're still selecting 3 cards, and you're still going to multiply because it's the multiplication rule of counting. But the first option, you have 52 cards. But once one card is dealt to you, there's less cards in the deck. So then there's only 51 cards left for your next choice, and 50 cards left for the next choice after that, right? Because every card that's dealt is one less card left in the deck for you to be choosing from. So 52 times 51 times 50 is 132,600. It's slightly smaller than the number with replacement. And either way, all of these figure out the sample space size without you having to actually create a tree diagram or anything like that. If you're going to come up with probabilities based on hypotheticals and logic, you need a way to find the size of your sample space in order to be able to find your probabilities. And the multiplication rule of counting will help us do that.